Okay, the next talk will be Dockerizing Python by Ambreen, Sheikh. So let's welcome her.
Hello and welcome to my talk, Dockerizing the Python. My name is Ambreen, Sheikh, and for the next 30 minutes, oh yes, no problem. Should I start again? Or? No. And for the next 30 minutes, I will be talking about Docker. What is it? What is the technology behind Docker? How and when to use Docker? And most importantly, why is it so darn famous? What is all this buzz around this word called Docker? And towards the end of the talk, I will also give you a demo regarding how to integrate a Docker into your daily Python development framework. But before moving ahead, I would like to ask all of you that how many of you are using Docker today? Yeah, quite a lot. I would say around 35 to 40%. So one of the reasons that I decided to have this talk was because these days there is a lot of there are a lot of hip and fashionable technologies and tools and frameworks and libraries out there. Every few months there is a new hipster framework that you need to learn or that you need to get yourself up and running with. And I believe that there is a lot of hype around these technologies rather than a deeper understanding of what these technologies are truly there for. So, and I believe that Docker is one of those tools that has fallen prey to this hype and this, it's kind of become a fashion to have Docker without really understanding what are we using Docker for. So my intention with today's talk is to provide you all with a deeper understanding of what exactly a Docker container is doing when you start it on your local computer or on your server. And I would really want to achieve this during my talk that when you go home today or when you go to your workplace tomorrow, you are tempted to try Docker and run Docker locally on your computer and see if it will help you improve your Python development framework. Maybe it will improve it. Maybe it will make your life miserable. So. Yes, so before digging deeper into the talk, there's a small introduction about what I do. I am a Java developer turned DevOps engineer. I mostly work with the continuous integration and continuous delivery pipelines and workflows. I work at a game development company in Stockholm called Quickspin. And again, there is a lot of hype and buzz around this word DevOps as well. And a lot of people are referring to their system administrators as DevOps. In my point of view, DevOps is a much needed and in many cases a mandatory friendship between developers and operators. I'm not going to go into the details because that will be a topic for a separate talk. So moving back to our main topic, which is Docker. During this talk, I will be talking about the containerization technology, virtualization technology. Why do people confuse containerization for virtualization? We'll look into that, and then we'll look into some use cases around Docker. Why are people using Docker, and what are the cases in which you can use Docker? Then we will we'll set up some Python containers. We'll set up some Python images and run Python inside a Docker using the whole Docker ecosystem, including Docker Hub. And towards the end, I would also like to give you a sneak peek into what Docker sucks at, why you should stay away from Docker and not really use Docker when it comes to your pipelines and local development frameworks. So first things first, Docker is not really a name of a technology. Docker is a name of a company, or at most I would say Docker is a name of a tool. Docker is a name of a tool. The technology behind Docker is referred to as containerization, and when an application is running inside a container, it is referred to as a containerized application. So the Docker tool provides you a setup to run your applications inside a container. The company Docker was formed around, I would say, 4 years ago. And if you come across job applications saying that they need 5 years of Docker experience, do not trust them, because they don't know what they're talking about. And I have seen them. Yes. So as I have talked about that, a Docker is a system that provides support for running containerized applications. When an application is running inside a container, it is just called containerized application. But the question here is that what is a container? If you look at the literal definition of a container, if you write define container into Google, what it will reply, or what Google will tell you, that container is an object that is used to hold or transport something. And this is exactly what a Docker container does for you, or a container technology does. It is an object that is used to hold and transport software applications. So when you are running or developing applications on your local computer, or on your local computer, on your local machine, or on a server, or even when you're deploying your application onto production through a server, your application needs a certain environment to be able to deliver the expected behavior. And that certain environment would include certain dependencies, libraries with particular versions that needs to be installed. You would need some environment variable configuration, you would need some path settings, you would need some directory formation. So this is the environment that is needed to run your application. And when you're able to take that environment and package it in some form along with your application, this is what is called a containerized application. So if you have, the main purpose of having a containerized application is that you are able to take your containerized application and run it on any server, and all you need is Docker installed and on that server. You don't have to go into environment variable settings. You don't have to install anything. You don't have to keep track of the versions of the dependencies or the libraries that needs to be installed. So this was a small definition, I must say, of what containers are. A lot of people also refers to containers as lightweight virtualization. I'm not sure if I fully agree with that, but let's see how that goes on. Because virtualization is another technology that has been around for decades now. And virtualization is when you're running a Windows on your local machine on a server, and you intend to run a application that is very much based on Ubuntu. You are going to create a virtual machine inside your server and run your application inside Ubuntu, and Ubuntu is running inside a Windows machine. That's what virtualization is. And if you look at the stack flow of virtualization, it looks something like this. You have the infrastructure. The infrastructure may be your local machine, your in-house server, or some server up in the cloud. On the top of infrastructure, you have the host operating system. This is the complete operating system along with its kernel and kernel modules. On top of host operating system, you have the layer called hypervisor. Hypervisor is a layer that supports and provides management for the running of multiple virtual machines onto your server. Now, in this case, there are two virtual machines. Application A is running inside virtual machine A, and application B is running inside virtual machine B. Application A is packaged packaged together with all the libraries and system libraries and along with the guest operating system. That may be different from the host operating system. Similarly, application B is bundled together with libraries and another guest operating system. So the problem or the issue with there are a lot of advantages of virtualization as well. But right here, we're looking at virtualization in context or in comparison with containerization. So the problem that I see with this stack is that there is redundancy in this stack. You have a host operating system, and on top of it, you have the complete package guest operating system, which means that virtualization or running virtual machine is expensive in terms of your CPU utilization or your hardware utilization. It is heavy, it is slow to boot. And if you have any experience of running virtual machine on your servers or local computers, you would have the understanding that running a virtual machine basically means bringing your computer to its knees, and that is because of the redundancy that we see here. So in comparison to virtualization, what the stack for the containerization looks something like this. On the very base, you have the infrastructure. On top of the infrastructure, you have the host operating system, and then you're missing the hypervisor. Because we're not running virtual machine, we do not need the hypervisor. And on top of the host operating system, you have a container A and container B. Container A contains application A plus the libraries. The container B contains application B plus the libraries, but the guest operating system in this case is missing. But you need something to run your containerized application on. So in order to develop a better understanding for what is happening here, I would like to display the stack for the Linux operating system. When there is Linux running on a machine, on very base you have the hardware. On top of it, you have the kernel modules and the kernel, and on top of it, you have the system libraries, the file systems, the processes, and the resource management. So in the case of the containers, the kernel and the kernel modules are shared between your host operating system and your containers. And the system libraries, file system, processes, utilities, resource management, and compilers are more specific to every container. So I would say that half of the operating system is shared among all the containers, and half of it is inside every container. While a few days ago, I came across a very interesting analogy that you should think of a virtual machine as a house, where it contains everything. From a house has its own roof, its own garden, and everything. While a container is like an apartment, where you are sharing a lot of things with other people as well, but still you have a lot of things that are of your own. And in this case, we can see that the kernel and the kernel modules are shared among all the containers. Another thing that I would like to talk about here is a Linux utility called chroot. Has anybody heard of that? chroot is a utility that provides isolation for your application, for your processes and your child processes to run in a certain environment. And a lot of people say that containerization or Docker containers are chroot on steroids. So if you're running containers, go home, have a look at chroot, because maybe all you needed was chroot and you have exhausted yourself with the concept of Docker and containers. So containerization is, as I've talked about, lightweight, isolated, cheaper, faster, and more efficient as compared to virtualization. And this is the stack of virtualization and containerization standing side by side. And we can see that two of the layers are almost missing. I wouldn't say completely, but almost missing in the concept of containerization. And that is why containerization is mostly referred to as lightweight virtualization. Virtualization is the abstraction of hardware layer, and containerization is the abstraction of application layer. So now moving ahead, I am going to talk about, or we're going to look into some very common use cases of Docker. And I think we have already talked about few of them this morning. The topmost use of a Docker is simplifying configuration management. What does that mean? When you are packaging your environment along with your application, you remove the need to manually configure each and every server. For example, if you have ever worked as a system administrator, you would know that, okay, you can set up virtual machines, you can set up containers, but most of the time, mostly due to the lack of the time, you end up manually configuring 10 servers in the same way. So what Dockerization or what containerization can help you with is that you create one configuration or one configured Docker container, and you run it on all the server, eliminating the need to manually configure each and every server, and providing the support for the application so that it can run in exactly the same manner on each server. The next use case of Dockerization is code pipeline management. If you have worked with continuous integration and continuous delivery pipelines, you would know that when you're writing a code on your local on your local machine, there are different steps that your machine goes through before it reaches the deployment server or the production server. And it is very important that your local environment is similar to your production environment, because if there is even one library that is running a different version from the deployment server, there is a very high probability that you'll end up messing things into the production environment. So when you're running an application in a container, you are given this guarantee that the environment that is provided to your application is going to be similar throughout the pipeline. The third use case that is getting really popular these days is running your development environment inside a container. And this is what we'll look at during the demo today. Many a times it happens, like, I don't know, because I work as a DevOps engineer, I think it's almost every few days I get to hear that it is working on my machine, but it doesn't work on that machine. It's work on my machine, but it doesn't work on the server. And when you hire new people, I don't know about other companies, but most of the time it happens that the new developer probably ends up spending at least 2 days to setting up the development environment, and at the end of 2 days, he's probably willing to quit very soon as well. So running your development environment inside a Docker container also gives you the guarantee or the assurance that you will have the certain environment without going through setting up that, without going through the process of setting up this environment. So now, as I talked about in the beginning, we'll have a detailed look at how you can set up container. We'll take a very small, very easy to understand example and run it inside a container. But before moving ahead, it is important to get familiar with another concept that is referred to as an image. Because you need an image if you want to run a container. An image is that package that contains your libraries, your dependency, your environment configuration, and you take the image and you run it inside a container. If you talk about an analogy here, or if you think of an analogy here, think of image as your class and think of container as your object. You can create multiple objects of a class, and similarly you can start and run multiple containers based on the image, and containers will replicate the configuration that is defined inside the image. Now the next question is that how to create an image or where to get an image from. There are two, or maybe I should say there are three ways where you can how you can end up having an image on your computer. The first one would be to creating an image from scratch. The second would be to download or to use an image that is already created by somebody else and that is uploaded on some registry, or in this case, we will be looking at Docker Hub. There are a lot of open source images available on Docker Hub. I'll log on to Docker Hub and we'll have a look at it in a while. And the third, of course, the most important thing, or the most important way of acquiring an image is to create your own image based on an image created by somebody else. And we'll have a look at one of those examples as well. Okay, so yeah, I think I can. I don't know.
Yeah.
Like this?
Yeah.
Okay. Okay, can you hear me? No. Hello? Yeah. Okay, I think this is much better and much comfortable. Okay. I have my, okay. So this is what a Docker Hub looks like. I have already logged into Docker Hub. I'm pretty sure those of you who work with Docker containers are familiar with what a Docker Hub is, and it's not very, the picture is not very, okay, this is not how it's supposed to look like, but okay. Maybe I try to, can I search Python? Is this the search box? No. Here is the search box. Oh well, but as I've talked about before, that Docker Hub is a central registry where you will find, I would say, thousands of images created by other people and companies and other companies. In our case, as I've talked about, that I will show you, or we'll look into setting up a Python container, and there is a Python image provided by the official Python people that you can use, and that image, it's not just one image. You can have an image of the Python based on version 2.7 to 3.5 to 2.4, or whatever particular Python version you intend to use. So what I'm going to do is I am going to pull an image from a remote repository. Right now, if you look at Docker PS, is a command that lets you know if there is a Docker container already running on my machine. There is none. And Docker images is the command that will show you if I have any images already existing on my computer. And I have an image called Python with the version or with the tag 3.5 already pulled from the Docker Hub. So what I'm going to do again is Docker pull Python 3.5. Oops. So what it will do is that it will pull the the Python image from the Docker Hub. But in my case, it was really fast. It usually takes around, I would say, 20 to 30 seconds to pull down the whole image, because I have already pulled that image. So what I'm going to do is that I'm going to run or initiate a container based on that image. So if I write docker run Python 3.5, we will not see anything happening, because we haven't really instructed our container to do anything with the image. It starts a container and it exits the container. But now I'm going to tell my container to run a command like show me the version of the Python that is running inside the container. Python version, and it displays the particular version of Python that is installed inside the Docker container. Another way that you can run your container is in an interactive mode. If you run the Python container in an interactive mode, you end up with Python interactive shell. You can write anything. Hello.
And then you can make it fail as well because this is older Python syntax. You can start your, you can do anything that you mostly do on your Python interactive shell. And this thing comes quite handy when you want to run, or when you want to find out the speed of a particular library, Python library that you're using. You just initiate a Docker container with that library inside it, and that version may be different from what you are running on your local system. Because right now on my local system, I am running an older version of Python, which is very different from the container that I just started. So another interesting way to run, or if you want to go inside your container and have a look at the file system of your container, you can start your container into the bash mode. So now I'm inside my container. The file system that I see here is of my container and not of my machine. So for example, if I run any command here, it will display me the output based on what is inside the container. But let's suppose if I remove the bin folder. I don't recommend doing that, but if I do it, I have basically corrupted my container. So, but that's the good thing, because I can exit and I can start a new container where I can just run these commands. So if you want to run these kind of commands and want to experiment, it's better to start a container rather than setting up a completely new system. So that was an example where I pulled a container from a Docker, where I pulled an image from a Docker hub and built a container based on that image. So the other way we talked about on how you can acquire image is you can build your own image based on a Docker file. So you have a Docker file with all your required configuration. For example, your development environment needs a particular type of environment variable. You can configure that inside a Docker file, create an image based on that Docker file, and run it inside a container. So I'm going to show you a small example of how that can be done as well. So I have a very simple Python application that is doing nothing but displaying a Hello Python Sweden message. So what I'm going to do right now is I am going to try to create an image and run this small Python application inside the container that I will create based on that image. So in order to create an image, you need a Docker file. If you look into this Docker file, the topmost command or the topmost line of that Docker file says that this image will be based on an image that is Python 3.5 and that you can pull from the Docker hub. And then I'm giving the Docker file some other instructions, like you can run, you should create a directory called Python work inside the root directory, and then copy my Python app inside the Python work folder, and then configure an environment variable called myvar as Python conference, and then run this application inside the container. So now we have a Docker file. I'm going to build an image based on this Docker file. So we will build the image and let's call it Python conference, and it will start with creating an image, and then it says that it has successfully tagged the image called Python conf. So what I will do is I will, what was it called? I forgot. Yeah, Docker run Python. So, and the container gets initialized, it configures the environment based on the settings that I had provided, and it runs the Python application, then exits the container. But I want to be, a bit naggy and want to be sure that it did set up the environment as I wanted it to be. So I am going to run the container in the bash mode, as we have just done it before. And if we look inside the root directory, there is a directory already created called Python work. If we go inside it, we have the same application called, okay, I don't have the VI installed in it, but that's another thing. And let's suppose if I want to display the variable that I configured called myvar, it's like Python conference. So basically all the settings or all the instructions that I gave into the Docker file are transported inside the Docker container, and the container is running the application that I asked it to run based on the settings that I provided into the Docker file. So now the second question would be that I've talked about running Python in your local development environment, that okay, this is an image, this is an application that you have created, but now you want to share this image and this application with a colleague that is sitting next to you. So the best and the most easiest option in this case would be to share this Docker file and this application, tag this image and upload it into Docker Hub. So I'm gonna, yes, we have some time, so I can continue. We can try to do that. I will tag my Python conf, and I will push it to the, so first I have tagged it, now I am going to push it. And let's see. Okay. Okay, it may take some time because depending on the speed of the internet, but coming back to the demo slides, this is basically what we have done. We created a Docker file, we inserted all the configurations that we want into the Docker file, created an image based on the Docker file, and then ran that image inside the container. What we're doing right now with this pushing the image to the Docker Hub is that we want to initiate, my colleague who's sitting next to me wants to initiate the same container, but without going through the hassle of creating a Docker file and creating the image for it. So, okay, it's still pushing, it's rather slow. I will come back to this in a while, and we'll see that how this image gets pushed onto Docker Hub and how you can put it again, and without having any hassle, you can set up the container. So towards the end, as I've said in the beginning, I would like to talk about why Docker is not good for you and what are the things that are not up to the mark in Docker right now. So first and foremost is that container isolation is weak, and that goes on to the start where I said that the kernel or the kernel modules are shared between different containers. So what happens if there is a bug in your kernel of the host operating system, then that bug will appear in all of your containers. So from that point of view, the container isolation is weak. The default container isolation is weak. There are many ways to improve this isolation, but by default, this isolation is rather weak. The second thing that a lot of people talk about is the container security, because the example for the container security would be that by mistake one of the containers, one of the users on the container have root access, and if they have root access, then they can hack into or go into the kernel of the operating system and run some commands that may affect the other containers. There are ways to protect this, but this is possible, and this can happen if you do not configure your containers very wisely, I would say. there is a lot of work that has been done regarding container security in Docker. The next thing, which is quite important, is the operating system part, because if any one of you has had a chance to run Docker on Windows, it is not a very nice experience, and I'm pretty sure you can all agree with that. There are definitely issues with operating system when you're running Windows on Linux or Linux or Windows. And the third part that I would say, introducing and setting up containers from the very beginning or from the very start is a bit of an uphill task. Somebody have to sit down. If you want to introduce containerized setup in your company, you really have to think about it, that do we really need containers? Will we really gain something from containers? Because it is a setup and somebody have to work on it full time in order to set these containers up. Yes, now it has successfully pushed to Docker Hub. I hope we can see it now. I mean, I don't. Yes, this is the Python conf public image that has triggered, that has been created on Docker Hub. So if I write, if I remove all the images from my if I remove all the images that I have locally on my computer, because this image is also existing on my so I would like to okay, they're probably running inside the container, so first I have to remove the containers. So so we remove the containers, and then we remove the images. So if I write Docker images, there are no images, and if I write Docker containers, there are no containers. But if I simply say Docker run copy, okay, that's not good. And sorry, really sorry about that. It just happened. So it cannot find the image locally, and it cannot. So embarrassing. Okay, still doesn't like it. But anyways. Yes. Okay. Yes, now it will pull the image, so we don't really have to pull it separately. If you just write run, it will look into your Docker repository, it will pull it and run your application inside the container. And it may take some time to do that. But anyways, okay. I would say that's about it, and I think yes, that's all. Thank you so much.
Questions?
Yes.
Yeah. So you can. I will go
have
around
to use
with this.
this.
Yeah.
Yes. Hello. Yeah.
Thank you for the talk.
Yes.
I would like to comment on the setup of containers, which can be overwhelming the first time.
Yes.
But there is a shortcut that exists. There is this library/script for Python, which is called Cookie Cutter. And what it does is it pulls scenarios from the web for how to set up different projects from the start. So when you start a new project, you just Google Python, Docker, or Django, whatever. And then you pull in a script and you run Cookie Cutter, the script from the net, and it will set up a full structure for your project with some Docker files set up already, so that you don't forget any best practices that are in there. And then you just customize this template for
And I think that's exactly a really good point, that there are a lot of these images, there are a lot of these tools that are available that can assist you. But I would say that it is a good idea to start it from scratch at least once, even if it is an overwhelming experience, to really fully understand what container does for you. I mean, there are, of course, a lot of libraries, but thank you for the comment. Thank you so much.
Yeah, you didn't show the layering of
Yes.
applications.
Yeah.
Because I haven't really. So my question is the layering of applications inside of the container. I haven't really fully grasped that when you do a run, and then basically you have to run all of the applications in one layer and then a second layer for some hierarchy. Could you explain that?
I would say that when you look into the Docker file, each command in a Docker file adds a separate layer on top of your image. For example, the Docker file that we had, it is based on another Python image that already exists in Docker Hub. So when I add another line in my Docker file, it adds one layer on top of this. When I add another line, it adds another layer on top of it. And if you want, you can just, depending on what level of configuration you want, you can define those layers. And if you look at this image, this is, I got it from the Docker Hub, and this is where you can see the layering in that concept. So, yeah.
I'm referring to what you said, that you should investigate if you really need containerization in your when you're doing this. So, and then setting up development environments. Have you any experience with alternate techniques and other methods that might, compare to this, easier or worse? Any experience there?
Well, there are many other tools, like there's another Python tool called virtualenv that you can use in similar manner, but I would say that's a very Python-specific tool. And if you're using a multi-range of development languages and development tools, then I would say that using Docker or Docker container is probably a better idea. But if you want something very specific to Python, then there are other tools that you can configure to run your local development environment inside it. Yes, there are. Yeah. But we, like at my work, we mostly have a Node.js JavaScript-based environment, and we are in the process of moving it inside a Docker container so that new developers can just, initiate the containers rather than going through each and every page or each and every step on the wiki page that is never updated because they're always outdated, the wiki pages locally in the companies. Yes, please.
Have you compared Docker and Rocket?
No, I have not. Have you?
No.
Okay. Has anybody else? No, okay. I actually am not familiar with Rocket, so. But you want to? It's close. Yeah, the Linux containers, the concept of, yeah. Well, the concept, like I said in the beginning, that Docker is using the containerization technology provided by the Linux containers. So in the end, it is maybe adding an extra layer. Maybe you want to use Linux containers for your work. But it again depends on what you want to acquire from the environments that you're working in. Yes. Okay. Thank you so much. Oh, okay.
We have one more question. Let's
Okay, because
a quick one.
Since you mentioned Docker on Windows, which fortunately I never have to deal myself, but didn't the people at Docker made something like Docker Toolbox,
yes.
which does a virtualization, yes. And then you have containerization?
Well, there are many ways to run Docker on Windows and run Linux containers and Windows containers together, but they are not as straightforward. There is a process that you have to go through. There are different layers and technologies that you have to, go through. It's not just you can just pull a container. No, it will not work that way. Yeah, there's a separate configuration for that part. Yes.
All right.
Thank you so
Thank
much.
you.